In this video, we're going to tackle the topic of putting ICs in a circuit and working on them with test equipment, hooking the test equipment up to it. So we're going to need to have a place to connect our wires that come from the test equipment, and you see them coming in here. And one of the first things we want to talk about are these little pin jumpers. They're just very simple little devices. They might be a little tough to find. They're called pin headers, is usually what people call them. And they come in big long sections, and I just cut them apart with a very nice flush cutter, and that works pretty well, and cut them to size. Sometimes when you try and break them with your fingers, you don't get them the right size. What's unique about these is they have long pins on both sides. A lot of these are usually made to put on a circuit board, and the pins on the one side are much shorter because they only come out of the edge of the board a little bit, but these are special. They're made long on both sides, and I should have given you, when I sent your test equipment to you, there should have been some of those in there. We definitely have more in stock in the lab. But anyway, we found out in the past that if we push these in the boards right by the pins that we're using on our IC, you can see here I put them in a row because I kept them away from the 5-volt connection. I put them in a row, and that allows us to conveniently push these little jumpers that come from the Analog Discovery 2 to push them onto those pins and have them stay on there without falling off. Now, there was an older technique that we used. Students sort of came up with this technique. We had a wire, and what we would do is strip a length of the wire off. I don't know if that's a good indication of the correct length, but we'd strip the insulation off that, just have that wire cut it off. And what students would do in the past is they would push this into the Analog Discovery 2 jack, and then they could turn around and push that anywhere they wanted on the board, and that works. The problem is when you take it off, the wire stays in the board, so every time you got to pick that wire back out and push it right back in the Analog Discovery 2 jumper, put it away, and hopefully they don't fall out, and do it. So when we found these dual long pin headers, we decided that was a much better solution. So you won't have one to put in for every IC that you put in, but you'll have enough to work with what you need. So that takes care of making connections to the pins that you want from the Analog Discovery 2. Now, just to make sure we do this in every video so we finally get people hooking these up right, first thing you want to do when you hook other test equipment on is you want to have a common ground. So the Analog Discovery 2 has ground connections. They're black leads, and I always fire one of these on down at the bottom by my meter lead, so you can see the ground of my Analog Discovery 2, the ground of my meter, is in a rail or a bus that holds the ground connection. So that means my power supply, my meter, and my Analog Discovery 2 are all connected together at the ground point, and they have to be. If you don't do that, you're going to get really weird results, and it'll drive you nuts, and I know people will still forget to do it. So that takes care of the ground connection. I always put it down at the bottom so it's out of the way, and hopefully it never gets knocked off. That usually isn't a problem. So what we do then is you have to figure out what signals you want to generate, what pins you want to place them on the IC that you have. So you have to know what the part number is and what the pinout is. This is an OR gate. I think it's 7432. I know that pin 1 is an input to the 2-input OR gate, pin 2 is another input, and pin 3 is an output. So I know which pins to connect them to from the IC, But when I work the waveform software, I also have to know what pins I'm creating signals or waveforms on to exercise this IC. So I usually go in order. I establish a convention that makes it easier to work with, makes it a little bit faster, but it also is less errors until I'm done. So my convention is always start with wire 0 from the analog discovery and hook that to the first input. Hook the second wire up, which is 1, hook that to the second input, and also take wire number 2 from the analog discovery 2 and put that on the output, which is the third connection that I want to make. You can hook the wires any way you want, as long as you remember which ones you generated waveforms on and which ones you want to measure the output on. But people don't do real good with doing whatever they want. They have to be told an organizational way to do it, or a standard way to do it, so that they don't make mistakes. Otherwise, they sit there all day, hook the pins up to the wrong pin on the IC, and it ends up that things don't work out too well. Your labs don't work right, and then you're sitting there trying to figure it out. Take our suggestions and see what's there. So we have the pins labeled, as we've shown you before in another video. We have back here, we have them grouped so that we know these are the digital inputs that we're using. We have our ground connection in common with all the other ground connections, and that should work pretty well. In the waveform software in the future, I'll show you, you probably should label the pins in the waveform software just like the pins of the gates, in a way that you can recognize and do that. And one of the final things that we do too is we usually have a schematic to build the circuit, and we usually mark up the pin connections from the wires from the analog discovery 2 from the test equipment that you put in. So hopefully this gives you a good start. And when we ask you to hook circuits up to ICs, you can get the IC in the board, you can get the equipment hooked up right, and you don't get anything wrong, so that you can get your signals pretty quickly and do it accurately, because that's what a technician has to do anyway. Also, for future reference, we're hooking up 3 wires in this example. We might hook up 15 or 16 wires until we're done, and we're going to want you to have them all right. You're not going to want to mix anything up, or that's not going to give you the right results. So hopefully that gives you a good start, and we'll see you in a future topic. Thank you.